Directions are to factor each polynomial completely and write unfactorable if it's not possible. So the first question on any factoring problem, is there a GCF? So between 2, 12, and 18, they can all be divided by 2. So I know I have a GCF of 2. Between the letters, x cubed, x squared, and x, each one of them has at least one x, so I can pull out a 2x. So if I divide each of these by 2x, 2x times x squared gets me 2x cubed. 2x times negative 6x gets me negative 12x squared. And 2x times 9 gets me 18x. So now I have to see, are my parentheses completely factored? Well, there's no GCF between 1, 6, and 9 other than 1, so I can't take out a greatest common factor, but that's a trinomial, so maybe I can work out Korean method. This actually is a special case because I can do the square root of 1, I can do the square root of 9. If I multiply those together, I get 3. If I double it, I get 6. So that was a special case. So that factors into x and x, and the square root of 9 was 3 and 3. To get a positive 9, the signs have to be the same, but add up to a negative 6, they both have to be negative. So to completely factor it, I took out my GCF of 2x, and then it factored into x minus 3, x minus 3, which if I wanted to, I could shorthand it and write 2x times x minus 3 squared. For number 8, same thing. What's the GCF? Well, 2 and 32 can both be divided by 2. I've got an m to the 4th and an m, so I can divide out an m. So I'm dividing each of these by 2m. So 2m times m cubed is 2m to the 4th. 2m times negative 16 is going to be negative 32m. Then I have to go in the parentheses and say, can that be factored? Well, it doesn't have a GCF, and it's not a difference of two squares because 3 is a cube, not a square. If that had said m squared minus 16, I could have factored it in minus 4m plus 4. But it's not, so that's as far down as I can go. So that would be m cubed minus 16. Then for number 9, greatest common factor between 4 and 100 is 4. Between x to the 4th and x squared, they each have at least an x squared. Between y and y, they have a y in common. So if I divide each of these by 4x squared y, 4 times 1 would give me 4. X squared times x squared would give me x to the 4th, and then y times 1 would give me y. Then I have a minus sign. 100 divided by 4 is a negative 25. X squared divided by x squared drops out. Y divided by y drops out. So now I have to check, am I done with my parentheses? Well, when you have a binomial in parentheses, first thing you check is GCF. So there's no GCF. The second thing you check, is that a difference of two squares? Well, there's a 1 in front of that x squared, so can you do the square root of 1? Yes. Can you do the square root of 25? Yes. That means that's a difference of two squares. Difference of two squares, you split up your x squared into x and x, and then you have to say, what can I multiply to get a negative 25? Well, if the sign is negative, then your two signs have to be different. So positive 5, negative 5. So to completely factor it, it was my 4x squared y, and then I was left with x plus 5 times x minus 5. For number 10, GCF is my first question. So 5, 3, and 1 doesn't have a GCF. It's a trinomial, so trinomial means Korean method. So the only way I can multiply to get 5 is 5 times 1. And this is nice because the only thing I can multiply to get negative 1 is negative 1 and 1. So this is my only choice. I could switch the negative around. But 1 times negative 1 is negative 1. 5 times 1 is 5. If I add those up, I get positive 4. So that didn't work because I'm supposed to get a 3 in the middle. So switch the sign. Make this one positive and make this one the negative. All that's going to do is give me a negative 4. So I've tried every possibility that I could possibly try with Korean method, and none of them worked. So I would say this is unfactorable.